3 there. So CO3 is a 2 minus. The valency, as you can guess, will be 2. So when you exchange their valencies, that will give you a NO2, Na2, see, Na is 2, CO is 1. So that give you Na2, then CO3, only 1. So that is how we arrive at Na2CO3. So can do similar thing for the rest. K will pick up NO3, H will pick up OH. H picking up OH gives us water. K picking up NO3, you need to investigate their valencies. K and NO3, you know valency is the combining power. That's what determines how they are going to combine. So valency of K is 1. Valency of NO3, you know NO3 is NO3 minus. Confirm that from a radical table. That will give us valency of 1. So that will just give us KNO3 when you exchange the 1 valency. Let's look at HCl and sodium. Okay, we'll look at this in another property of an acid. Then let's see this finally. H3PO4, that means you break this into H and PO4. NaOH, that means you break Na and OH separately. So H will pick up OH. No, don't worry about the 3 that is there. First of all, combine the units first. That gives us H2O. Then PO4 is a unit, is a radical. Na2 is an element. So Na will come first. PO4 will come next. Sodium valency is 1. We have explained before. It's number 11281. PO4 is a radical. The charge on it is 3 minus from your radical table. So you can guess the valency. Now valency will be 3. So when you exchange the valency, you will be having Na3, PO4 only once, plus water here from H and OH combining. So once you have done that, then you now need to balance it. So balance it. There's 3 hydrogen here, then there will be 3. There's 3 hydrogen and 3 hydrogen here, making 6. So there will be 6 hydrogen in that place. 3 sodium here and 3 sodium here is balanced. PO4, a PO4. So you can balance it using algebraic method, or you can use atom counting. So that is how we do acid-base reaction. Finally, you see that the K will pick up Cl. K is number 19. That's a 2881. Valency is 1. Cl is a simple ion, a simple atom, is number 17. That will be a 287. Of course, when it's 287, the valency will be 8 minus 7. That will be 1. So we are saying that K has a valency of 1 from a 2881. Cl also has a valency of 1 from a 287. 8 minus 7 is 1. So that gives us KCl. So we are saying KCl in this place and water. So that's how you do acid-base reaction. In the laboratory, to react an acid with a base, if the base is a soluble base, if it can dissolve in water, you use the method of titration for an acid-base reaction. In titration, you put the acid in the burette. This is the burette. You pipette the base into a conical flask. This is conical flask, or if you like, an Erlenmeyer flask. So you pipette the base into an Erlenmeyer flask. Then you be releasing the acid from the burette little by little until the color of indicator which you will have added to the base will change. So when the color change and you see the noticeable color change, you stop titration. That is called the end point of the titration. End point is a volume at which the color of indicator changes. That is the meaning of end point. You can see the color now from blue here to purple here, just for instance. So that is the end point of a titration, and that shows you where the acid have completely reacted with the base in that case. So that is the meaning of endpoint, and that is how you do an acid-base reaction when the base is soluble in water. So let's see the second property of an acid. Acid plus metal will produce salt and hydrogen. Acid reacts with metals to form salt and hydrogen gas. As you can see here, zinc is a metal. Zinc is a metal. HCl is an acid. You call this type of reaction a displacement reaction, a single displacement reaction. You will see why we call it displacement now. You see zinc here, you see hydrogen here. This zinc will come and take the place of hydrogen to give us a zinc Cl2. Then the hydrogen will be displaced away from the compound, and you see hydrogen standing alone. That is a displacement reaction. That means we have displaced hydrogen from the acid. So you call that displacement reaction. You will know that hydrogen has been displaced because hydrogen as a gas has its own property. It is colorless and is odorless, and it makes pop sound when you put lighted matches into it. So let's look at this very, very well. When metal reacts with acid, it gives you salt and hydrogen. Now the kind of salt that will be produced here will depend on the kind of acid present in the reaction. But hydrogen gas will always be liberated in that case. When a metal reacts with dilute acid, the acid must be dilute, not concentrated. Please take note of that. When the acid you use is an hydrochloric acid, then the salt you produce will be a chloride salt. It will be a metal chloride. Talk about sodium chloride, talk about potassium chloride, talk about calcium chloride. Once the acid you use is hydrochloric acid, then the chloride of this metal will be formed. If this metal is calcium, for example, you are expecting a calcium chloride here. If this metal is magnesium, for example, you are expecting a magnesium chloride here. So that's what we mean by the product depends on the acid you use. If you use tetraoxosulfate acid, your salt will be a sulfate salt, a tetraoxosulfate salt. If I use H2SO4 here and I use say magnesium here, then I'm going to be having a magnesium tetraoxosulfate 6 if my acid is H2SO4. Please take note of that very, very well. Then if I'm using nitric acid, which is trioxonitrate 5 acid, a very dilute nitric acid, very, very dilute nitric acid, and I'm adding Mg, then I'm going to get a magnesium nitrate, magnesium trioxonitrate 5 plus hydrogen. So take note of that. The kind of acid you use determine the kind of salt that is formed. A salt is any product you get when acid reacts with a base or with metal. So let's see some examples of metal acid reaction here. Look at here, magnesium reacts with hydrochloric acid. So you are expecting a chloride salt. So Mg will send hydrogen away by combining with magnesium, gives you magnesium chloride. The hydrogen, because Mg has taken its place, hydrogen will now be standing alone. That's a displacement, a single displacement reaction. Look at another example. Aluminium here is reacting with hydrochloric acid. So you're also expecting a chloride salt to be formed, aluminum chloride. Now, aluminum will send away hydrogen and combine with chlorine to give us aluminum chloride plus hydrogen that is being sent away. You are going to know that hydrogen gas has been formed because there will be rapid bubbles of the gas coming out. You call it effervescence in chemistry. Effervescence, rapid bubbles of gas coming out is called effervescence. So let's see another example here. Zinc reacting with H2SO4. What kind of salt are you expecting? Of course, a sulfate salt, because the acid is